Okay, so I'm going to talk about the Hardy-Weinberg principle, and we'll just start by talking about the different kind of frequencies we look at. So when we're talking about allele frequency, it's really important to remember this equation, P plus Q equals 1, where P is our dominant allele, so that's like big A, and Q is our recessive allele, so little a. And allele frequency is how often a specific allele occurs in a population. So that's looking just specifically at the alleles. When we talk about genotype frequency, the equation to remember is P squared plus 2PQ plus Q squared equals 1, where P squared is the homozygous dominant genotype. So this is like big A, big A. 2PQ represents our heterozygous genotype. So big A, little a. And Q squared is our homozygous recessive genotype. So little a, little a. And genotype frequency is how often a specific genotype occurs in a population, so we can look at exactly what those genotypes would be. So I made a little practice problem. It's really simple, but we'll just go through it to kind of see how this all connects and makes sense. So in a population of cats, 36 of them, of the 200, are gray, which is recessive, and the rest are white, which is dominant. So how do we start this? So we look at our allele frequencies, and we remember our equation P plus Q equals 1, and P squared plus 2PQ plus Q squared is 1. So we know that our Q squared, that's our recessive genotype, is 36. So we do, Q squared is 36 divided by 200, which, when we calculate that, equals 0.18. And then from there, we can find our Q, so we can plug it into this equation. So the square root of since we have squared here, we're going to square root that, and that, our Q is 0.42. Now that we have our Q, since we can plug it into this equation, we can find our P. So we have 1 equals P plus 0.42. So that makes our P equal 0.58. So those are our answers here. Our Q, or our recessive genotype, is 0.42, and P, our dominant, is 0.58. This is our alleles, not our genotype. So then we can go down to our genotype frequencies, and we can take this equation. So we know that P is 0.58, so P squared is 0.58 squared, which is 0.3364, and our Q is 0.42, so that squared is 0.1764, and we can plug these into the equation to find what our genotypes are going to be. So we have 200 cats total. We multiply that by 0.3364. And that means we're going to have 67 cats that are homozygous dominant. So big A, big A. Then we can figure out how many recessive homozygous we have. And we actually already know that. This one comes out to 35 cats are homozygous recessive. And then to find our heterozygous, we do 2PQ. So that is going to look like 2 times our P, which is up here, 0.58, times our Q, 0.42. Multiply all that by the total population. When we do that, it comes out to be 97 are heterozygous. So if we want to know how many are white, we can add up our heterozygous and our homozygous dominant. So we have 164 that are white, and gray we have 35. So that is how the Hardy-Weinberg principle works in practice.